Now we have to see here some multiple choice questions on 2 points, derivative of composite function first, and second function is derivative of inverse trigonometric functions. Okay, now we see first example here. If y is equal to 3 minus 6x bracket raised to 2 by 3, then dy by dx is equal to question mark. Now we have to give one options here. First option A, 4 upon cube root of 3 minus 6x. Second option is minus 4 upon cube root of 3 minus 6x. Option C, 2 upon cube root of 3 minus 6x. And option number D, fourth option, minus 6 upon cube root of 3 minus 6x. Okay, now answer for this multiple choice question is option D. How to get this option? Now we have to find derivative for this composite function. Differentiate this equation with respect to x. Derivative of y is dy by dx, and this is composite function. Suppose this 3 minus 6x as f of x, we get f of x raised to n. Derivative of f of x raised to n is n into f of x raised to n minus 1 into f dash of x. Using this formula, we can write here derivative for this function n into 2 by 3 into 3 minus 6x bracket raised to 2 by 3 minus 1 into derivative of this 3 minus 6x. Derivative of 3 is 0 and derivative of minus 6x is minus 6. Okay, that is we get here dy by dx is equal to 2 by 3 into 3 minus 6x bracket raised to 2 by 3 minus 1, taking addition here we can write minus 1 by 3 into minus 6. Okay, that is dy by dx is equal to, you can write here minus 6 into 2 by 3 into 3 minus 6x bracket raised to 1 by 3. That is dy by dx is equal to, we can write here 3 1s are 3, 3 2s are 6, we get here minus 4 into 3 minus 6x bracket raised to minus 1 by 3 means we can write here 1 upon 3 minus 6x bracket raised to 1 by 3. That is equal to minus 4 upon cube root of 3 minus 6x. This is the answer. That is, our answer is here option number B, minus 4 upon cube root of 3 minus 6x, not this option D. This is the correct answer. Okay, now we see second example here. The next second example, if y is equal to cot of log x to the base 10, then dy by dx is equal to question mark again. Okay, now this is composite function. We have to give one options here. Option first, A, cosec square x of log x, cosec square of log x upon x into log 10. Second option, B, cosec square log x to the base 10 upon x into log 10 upon x into log 10. Okay, option C, minus cosec square log x to the base 10 upon x into log 10 to the base e. And option D, minus cosec square of log x upon x into log 10, okay. Now we have to choose correct answer here out of these 4 options. Now we have to find derivative for this composite function. Suppose this log x to the base 10 as f of x in mind, then we get cot of f of x. We know that derivative of cot of f of x, which is minus cosec square of f of x, that is log x to the base 10, into derivative of this log x to the base 10, that is dy dx of log x to the base 10. Okay. Now here we have to use change of base theorem rule. Log x to the base 10 can be written as in the form log x to the base e upon log 10 to the base e. Here at left hand side, dy by dx equal to minus cosec square of log x to the base 10 as it is, and by using change of base theorem for logarithm, we can write here this log x to the base e upon log 10 to the base e. Here dy dx as it is. Then we have to find derivative of this term. Derivative of log x, 1 upon log 10 is a constant term, and derivative of log x is 1 by x. Okay, therefore we get here dy by dx is equal to minus cosec square of log x to the base 10 upon derivative of log x is 1 upon x, therefore we can write here 1 upon x into this constant term log 10 to the base e. Okay, now correct answer is option C. Here minus cosec square of log x to the base 10 upon x into log 10 to the base e. Okay, so this is the correct answer for this example. Now we can find the derivative of this function, composite function, in mind shortly, and we can get this answer directly. We cannot write all these steps. We can write here cot of f of x, derivative of cot of log of x to the base 10. We have to know change of base theorem. We can write here this log x upon log 10. Derivative of cot of f of x minus cosec square of f of x, that is minus cosec square of log x 10 to the base 10 into derivative of log x upon log 10. 1 upon log 10 is a constant term as it is. Derivative of log x is 1 upon x. We can write directly this answer. Okay. Now we see next example. The third example is again composite function. If y is equal to under root tan of under root x, then dy by dx equal to question mark. Okay, now we have to give one here options. Option number first, that is A, sec square of root x upon 4 into tan of root x, 4 into under root tan of root x, under root tan of root x. Option B, sec square of root x upon 2 into under root x into 2 into under root x into tan of under root x. Option C, sec square of root x, sec square of root x upon 4 into x into 4 into under root x into tan of root x. And option D, which is sec square of root x, sec square of root x upon 2 into tan of 2 into under root tan of root x. Okay, now we have to find the correct option here. That is, we have to find derivative of this composite function. We can write directly here. Derivative of y is dy by dx, and this is a composite function. Suppose this tan of root x is a f of x, and we know that derivative of under root f of x is 1 upon 2 into under root f of x. That is 1 upon 2 into under root tan of under root f of x into derivative of f of x, that is derivative of tan of root x. Derivative of tan of root x is sec square of root x into derivative of this root x. Derivative of root x is 1 upon 2 into root x. 1 upon 2 into root x. Okay, that is, we can write here dy by dx is equal to here sec square of root x upon 2 into 2 4 into under root tan of root x into under root x. We can write these two terms in one side, under root one sign, that is under root x into tan of root x. We get answer in two steps. Which option is correct? Dy by dx is equal to sec square of root x upon 4 into under root x into tan of root x. This option, option number C, is correct answer. Okay, we can find derivative shortly like this. Now we see next example here.